In this tutorial, we will be taking a spooky scene and giving it that extra haunted touch by creating interactions that respond to where the player is looking using the core interaction system. And you won't need to know how to code in Lua to do it. The interaction system allows you to design responsive interfaces for your game based on where players are standing, looking, or where the mouse is, both in the 2D layer and in the world. You can learn more about this system in the interaction system reference, linked in the description below. If you already have a spooky environment, you could use it and follow along with this tutorial, making your own version of each of these interactions. To follow along with the tutorial exactly, you will need to download the starter project. To open it, in the Create menu, select Community Projects. Search for the word Haunted to find Haunted House Tutorial Start by Core Academy. Give your project a name and click Download to make your own copy of the project. Now that you have downloaded the starter project, let's take a look at what is inside. Press the play button or the equals key to start a preview and walk around the haunted house. You will see that your game is in first-person mode, that there are a couple of objects in the room, and an empty auxiliary room. Press equals or the stop button to stop the preview. Looking in the project, you'll see in the hierarchy that we have a nighttime sky to create the spooky atmosphere, the outdoor environment, which includes the land and the trees all around, and the house interior, which is what we'll be working with on this project. In project content, you'll find the curve animation tool, which will allow you to move, rotate, and scale objects using Core's curve system. To finish setting up the project, add the interaction system. In the core content window, search for Interact to find the interaction system package and drag it into the hierarchy. The interaction system comes with several examples, which you can add into the game to test, and which we'll be using later to create our interactions. In this tutorial, we'll focus on the look interaction and the trigger interaction. The first thing we're going to add is an ominous lightning strike whenever the player looks at the main window. To do this, we'll add 2 effects to the screen with one more optional effect if you don't mind flashing lights. To start out, we'll go outside where the lightning is going to be and add the lightning VFX. In core content, search for lightning and drag the lightning VFX into the scene where you want the lightning to be. This VFX has several settings which can change the speed, color, and randomization to look as natural or supernatural as you want. The next thing we need to do is add the sound. The sound that we're looking for is called Nature Thunderclap Boom Set 01 SFX. Search for Thunder in core content and drag the audio into the hierarchy. This audio has multiple types that you can select in the Properties menu. In this case, we'll use Thunder Close Powerful, but you should test the other options to decide which one you prefer. The important thing is to keep spatialization, attenuation, and occlusion enabled, because they will make the thunder sound like it is coming from a space in the world, and to get muffled by things that block it, like the walls. To put it in exactly the same place as the lightning, we'll select the lightning VFX, and in the Properties window, click this blue paper icon to copy its properties. Once you've done that, select the thunder, and click the blue clipboard icon to paste those properties. Properties that both objects have but are different will show up in bold, like position does here. Check the box next to the position and click Paste Selected Parameter Values. You can now swap between selecting the lightning and the thunder in the hierarchy to see that the position widget doesn't move. To see the effects together, you can now preview in place with Shift equals, and you will see and hear the lightning thunderclap in the scene. The optional third effect is a big flash when the lightning strikes that illuminates the room. This could, because of the way the player will be interacting with it, fire over and over. So you may want to add a flashing lights warning if you use it. To add it to the project, search for Explosion Kit Flash VFX and add it in place the same way we did with the thunder. Once you have all the FX you need, select them in the hierarchy and press Ctrl-G or right-click and select New Group containing these. Name the group Lightning FX. The last thing we need to do is to put the group in a client context. Client context folders allow animations, visual, and audio effects to be played on an individual player's computer without requiring them to be synchronized across a network, and lets you make spectacular displays without making the game lag. Right-click the Lightning FX group and find the Create Network Context option. From there, select New Client Context containing this. Now that we have the lightning grouped in a client context, we can work on making the lightning play whenever the player looks out the window. To do that, we'll be using the look interaction. To create this interaction, we'll start with the look interaction example and then modify it. In project content, open My Templates and find the Interaction Systems folder, and in the Examples folder inside of it. Select the look interaction example and drag it into the scene near the window. press play or the equals key to test the example. By default, the sphere changes color whenever you are looking at it, and changes color again if you press a key while you're looking at it. The first thing we do is de-instance the template. We will need to do that in order to make any changes. Right-click the Look Interaction example and select De-instance this object. Once you've done that, you can right-click again and select Abandon Template for Entire Instance to avoid overwriting the example with the changes you make for the window interaction. If you open the Look Interaction example group, you'll see it contains two folders. A static context folder, which holds the collision that we need to detect where the player is looking, and a client context folder, which holds all the visual elements that we have seen. We can delete everything inside the client context folder, including the scripts. Next, we need to find the components. In Project Content, find the My Scripts section, which also has a folder for the interaction system. Open this to find the Components folder, which contains several scripts that you can use to make changes based on interactions without coding in Lua. We're going to be using the Toggle Effects components to turn all our lightning effects on and off. We will drag this script into the client context of the Look Interaction example, and then we need to set up its custom properties in the Properties window. The first thing it needs is the component root, which will be the Look Interaction example itself. Click and drag Look Interaction example into this box to add it as a custom property. We can rename it now to Lightning Interaction by pressing F2 or right-clicking and selecting Rename to keep the project organized. Next, we'll need to select the type of interaction. Close to where we found the components in Project Content, in the My Scripts section, find the interaction system and then select the Modules folder. Here you will find the API scripts for the 4 types of interactions available. We're going to be using the Look interaction, so select API Look Interaction script and drag it into the API Interaction module property. The next thing we need to do is specify what effects should be toggled by the script, which is our Lightning FX group. Select this and drag it into the effects property. Once we have set up those properties, we need to select when in the interaction the lightning should play. Hover, in this case, talks about when the player's look direction is intersecting the collision object. Check the box by Play on Begin Hover to play the effect when the player first starts looking at the window. The last thing we need to do is make it so that the collision lines up with the window, so that it only happens when the player is looking at this window. In the Static Context folder, select the collision group and change the visibility property from Force Off to Force On, which will show the red cube in the scene that represents the collision. Center the cube on the window and expand it to match the area that you want to trigger the interaction. Then change the collision back to Force Off and press equals to preview the scene. Whenever you look at the window, you should see and hear lightning. In this next step, we'll take all of the candles in the room and make them go out at once. To do this, we need to find them in the House Interior folder. Type candle into the search, and you'll see that each fantasy candle lit has a client context folder with candle flame VFX. If we select this client context and then click the X in the search to clear it, we'll see that this client context also has a point light that produces the illumination. We need to move both the flame VFX and the point light into a new folder to turn them all out. Select the candle flame VFXs and the point light and drag them into the bottom of your hierarchy. Repeat these steps, search, and then dragging the contents of the client context folder until you have 5 candle flame VFXs and 3 point lights at the bottom of the hierarchy. Select them all and press Ctrl-G or right-click and select New Group containing these. Name the group Candle Lights and drag it into the client context folder that also contains your Lightning FX. Next, we'll make this happen when the player walks close to the candle on the table using a trigger interaction. To do this, we'll find the trigger interaction example in the My Template section of Project Content and drag it onto the table. Press equals or the play button to start a new preview, walk up to the cube to see it change color when you are close, and change color again when you press the left mouse button while you're close to it. Once you've done that, we'll do the same thing we did before. Delete everything inside of the client context folder except for the trigger. And select deinstance and delete to deinstance the template at the same time when the prompt pops up. Next, open the static context and turn the visibility of the collision group to Force On. Select the whole trigger interaction example to move both the collision and the trigger together and position them on top of the table. Then, force visibility off on the cube. Next, we'll use a new interaction component. In Project Content, find the Toggle Visibility component. Drag this into the Client Context folder of the Trigger Interaction example. Let's rename the example to candle interaction so that it's clear, then select the toggle visibility component client script and drag the candle interaction into its component root property. The next thing we'll do is to select the type of interaction. We'll find the API trigger interaction module in project content and drag this into the API interaction module. Next, we need an object to toggle, which is the candle lights. The last thing we need to do is to specify when in the interaction it should happen. We want the candles to go out the moment the player gets close to the table, so check the box for hide on begin hover. Start a preview and walk up to the table to see all the candles suddenly go out. Now we have the candle flames eerily disappearing before our eyes. The next thing we'll do is to reveal a secret room behind the bookcase by blocking this door and creating an interaction that makes it lurch to the side. Find the bookcase object in the hierarchy. Here, I am in object select mode, which selects only the object which you click, and then using the left arrow to walk up the hierarchy and select that object's parent. You can toggle object select mode with the C key. We'll drag this bookcase into the client context that holds the lightning FX and the candle lights groups. Next, find the curve animation template in the My Templates section of project content and drag it into the same client context folder. Drag the bookcase into the curve animation's object property. We'll also check the box for play on start so that we can see and tune the animation first, then make it happen with an interaction. Change the duration to 3 for 3 seconds. Next, we need to figure out how much to move the bookshelf. If you select the bookshelf and drag it with the green arrow, it should slide side to side. Press the W key if you don't see these arrows. We can look at the position part of the bookcase and see that the Y is decreasing as we move it away from the door. You could look at this number to estimate how much it moves, or you could try enabling snapping with the G key or the button at the top, setting the snap to 100 and testing how many times it has to move to get in the right place. We can see it's about 200 centimeters to the left that the bookcase needs to move. From here, we'll select the curve animation and change the position multiplier of the Y to -200. By default, each property has a linear curve going from 0 to 1, and we can see what it looks like when the bookshelf moves. Press Shift equals to preview right where your camera is right now. You can see the bookshelf slide slowly and smoothly to the left. We can fine-tune this movement with the curve. Click the Edit button next to the Position Curve Y to see the curve. We can right-click the line to add a key. What we want to do is start out very slowly at first, so the second key stays close to 0. Click the Use Cubic Interpolation button to adjust the slope on either side of the key to get the messy lurching movement we're looking for. Keep previewing and adjusting the curve and duration properties until the motion looks the way you want it. Once we finish this test, we will disable Play on Start. The next step is to create a custom event name that, when broadcasted, moves the bookshelf. We'll call it Move Bookshelf and copy it to be pasted into another custom property later. To trigger the bookshelf movement, we'll use the candle interaction trigger, but have it activate on the end hover event when the player walks away from the candle again after getting close to it. To do this, in project content, find Broadcast Event Component. Click and drag this into the client context folder with the toggle visibility component. One trick you can do to copy information from one of these components to another is to select one that already has the custom properties fill out, press the blue paper icon in the top right corner of the properties window to copy all of its properties. Select your other component and press the clipboard icon to paste the properties. Check the boxes for component root and API interaction module, and then click Paste Selected Parameter Values. We already know when we want this to broadcast, when the player leaves the trigger. So check the box for Broadcast on End Hover. Finally, we need to paste the event name we added to the curve animation, which was Move Bookshelf. Now we can start a preview and test moving towards the candle and then away from it to make the bookshelf slide open. With the bookcase moving at the right time, we can make it more obvious to the player by adding some sound effects. There are 2 great sound effects that will help make the sound of an old dusty bookshelf moving on its own. Large wooden door, shut, open, close, rattle 01 SFX, and heavy wooden object drag loop 01 SFX. Find these 2 audio effects and drag them into the hierarchy. When you add the audio, you can press V to see the sphere that represents the range of the sound. We will create a group containing both of these and name it Door SFX. We'll put this group in the client context folder along with the other FX we've created. To make the audio draw the player's attention to the bookshelf, it's important that it be in the same position as the bookshelf itself. Copy the properties from the bookshelf and paste the position into the door SFX group to move them both at the same time to the bookshelf. Finally, we'll add a third component to the candle interaction, the same toggle effects that we used before for the lightning. Add this component to the client context and copy and paste the component root and API interaction module from either of the other two components. And check the box for play on end hover. The last thing we need is to give it a reference to the effects, so drag the door SFX into the FX property. Start a preview, and you should see and hear the bookshelf move to reveal the hidden room. Although moving all of your interactions and animations to a client context is very efficient, the one problem is that objects in a client context cannot have collision. So players could walk right through the bookcase and into the secret room. To solve this problem, we'll move the bookcase out of a client context and make it networked. Select both the bookcase and the curve animation template and drag them out into the bottom of your hierarchy. The simple way we could do this is to right-click the bookshelf and select Enable Networking. This will warn us that it will network the object we selected along with all of its descendants. When we right-click the bookcase again and click Count Objects under Selected Object, we'll find that it creates 27 networked objects. 27 networked objects might not sound like a lot when your total limit is 4,000, but it's multiplied by the maximum number of players. If we change the max players to 32, we'll find that it takes up almost 900 networked objects and nearly a quarter of our total networked objects budget. We can reduce the whole bookcase to 3 networked objects by moving most of it into a client context and adding one more object to act as collision. Open the bookcase object and select everything in it. Right-click and in the networking section, select New Client Context containing these. This will warn you that you will disable networking for all the children of the client context, which is exactly what we want to happen. You should now have 2 networked objects, the bookcase parent and the client context folder itself. Because every object is in a client context, however, the bookcase once again does not have collision. To fix this, we'll add a static context. Right-click the bookcase and under Networking, select New Static Context. Next, search Cube in Core Content and find the bottom aligned cube and drag it into your static context folder. Scale the cube up and out to make it consistent with the shape of the bookcase. Once you've done that, you can select the cube and change visibility to Force Off. The last thing we need to change is that the broadcast from the trigger is no longer going from client context to client context now that we've moved the bookcase out into a networked context. Client-to-client communication uses no networking and is essentially just one client script talking to another. Once you are broadcasting to the server, this is traffic across a network and will be synchronized across all players in the game. The only thing we need to do to change this is to select the broadcast event component in the candle interaction and check the box next to broadcast to server. Once we've done that, we can start a preview, walk up to the candle, and walk away to see the bookshelf moving again. The final interaction we'll add to the scene is a creepy rocking chair that will be rocking whenever the player is looking away, but stop rocking as long as they are looking directly at it. To do this, we'll use the curve animation template again. Start by selecting the rocking chair in the house interior folder and dragging it into the client context folder with our other VFX groups. Find the curve animation template in the My Templates section of project content and drag it into the same client context. Drag the rocking chair into the object property of the new curve animation and check the box for should loop so that it rocks continuously, and play on start so that it starts right away. We'll set the duration to 3 for now and create a custom start and stop events called Start Rocking and Stop Rocking. Next, we need to create the rocking animation. Select the whole rocking chair and press E or click the rotation button to enable rotation. Make sure that your transforms are set to local, not world, so that the rotation is relative to the rocking chair's orientation. You can swap this with the button in the top toolbar or by pressing T. Once that's set up, you can start adjusting the rotation and watching how it changes in properties. Here you can see that this is the X rotation that's changing by about 60 degrees. In the curve animation script, find the custom rotation section and change the rotation multiplier to 60. Next, click the Edit button next to Rotation Curve X, and in the top right corner, click the Curve Presets button and select Ease Out In. Take the final key and move it down to 0 by setting the time property in the top left corner to 1 and the value to 0. Start a preview to see the chair rock. You can edit the curve to make the rocking more irregular or customize it however works best with your scene. For the interaction, we'll once again use the look interaction example. Find it in the My Templates section in the Interaction Systems folder and drag it near the rocking chair. As with the other interactions, right-click to de-instance this object, then right-click again to abandon template for entire instance. Delete everything from inside the client context folder. Next, we need to adjust the collision, turn its visibility on, and rotate it to match the rocking chair. We'll expand it up considerably so that anytime the player is looking at all towards the rocking chair, it freezes. Then we'll change the visibility back to force off. Next, we'll get another copy of the broadcast event component and drag it into the look interactions client context. We can rename the look interaction example to rocking chair interaction. We'll add the look interaction module to the API interaction module and make the rocking chair interaction the component root. Check the box for broadcast on begin hover and set the event name to stop rocking. When the player starts looking, we'll tell the animation to stop, and when they stop looking, we'll tell the animation to start. To do this, we'll duplicate the broadcast event component, change the broadcast to on end hover, uncheck the box for on begin hover, and change the event name to start rocking. Press Shift equals to start a preview in place and test that the chair freezes when you look at it and starts rocking when you look away. The final touch on your creepy scene should of course be background music. There's a wealth of creepy and customizable background music on Core, which you can find in the audio section of Core content, both under ambience backgrounds and in the music section under BGM. Try just searching for dark and seeing all the audio options that come up. For this project, we'll add 2 different background audio tracks: Ambient Dark Breathy Cave Dungeon Loop 01 SFX, and press play in Properties to preview the sound. Next, add the Tense Desolate Horror Wasteland. This audio contains options for several different piano chords that can be played, but also an option to choose one at random. Change the type to Random Single Piano, and with the repeat option enabled, this should continually pick at random one of the chords and play it. Place both audio files in your client context. Select both audios, and we'll disable spatialization, attenuation, and occlusion because we want them to just play in the background the same way no matter where you are. Enable autoplay and repeat on both, and the music should sound like this. And that's it. You finish building a complete spooky scene. You can continue adding more interactions like these, or publish now using the Publish button in the top right corner. If you want to share your work from this tutorial, see the description below for a link to a forum post where you can discuss and share ideas from what you learned here.